Alright, so what we're going to talk about today is scientific notation. Now I know this is our first video, so I wanted to tell you before we start that I'm not going to stop and give you time to write down everything that I'm saying as I say it. So instead, what I need you to do is pause the video when we get to a new section, write down what you need to write down, and then push play and I'll continue. For example, right now you have your focus thought in front of you. So go ahead and pause it right now. Write it down, and then I'll continue. So, scientific notation. Our focus thought. What is scientific notation, and why do we use it? Let's look at our vocab first. Here we have two things, positive exponents and negative exponents. Positive exponents we should be familiar with. This is simply 2 raised to the 4th power, or 2 to the 4th. And then we also have 10 raised to the 5th power, or 10 to the 5th. What this means, 2 to the 4th, is 2 times 2 times 2 times 2. That's 4 2's. Okay? So 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th is 16. Okay? Now 10 to the 5th, same thing, except this time we have 5 of them. 10 times 10 times 10 times 10 times 10. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000. So we have 100,000. And you'll notice something about the relationship between the exponent of 10 to the 5th and the number of zeros in 100,000. There are 5. 5 is our exponent, and there are 5 zeros. So every time you have 10 raised to something, it's going to be the same number of zeros as is in the exponent. Now, negative exponents. We haven't really looked at these before, but it's very simple. Negative exponents are the same as positive, except you put them in the denominator of a fraction. So essentially, 2 to the 4th becomes 1 over 2 to the 4th. 2 to the negative 4th becomes 1 over 2 to the 4th. And from earlier, we have 2 to the 4th equaling 16. So 1 over 2 to the 4th is 1 over 16. So 2 to the negative 4th is 1 over 16. Do I have a negative here? No. The negative in the exponent simply means 1 over whatever that exponent is, 2 to the 4th in this situation. Okay. So for our next one, 10 to the negative 5th, we simply do 1 over 10 to the 5th, which is 1 over 100,000. And you'll see why these are useful here in a second. Next for vocab, we have significant figures, or sig figs, as I like to call them. In this number, 46,600,000, there are a lot of digits here, but only 3 of them are important. 4, 6, 6. All of these zeros are simply placeholders. These 3 digits are our significant figures. Okay. So scientific notation, what is it? Well, scientific notation is the way scientists and mathematicians easily handle very large or very small numbers. So using our example earlier from sig figs, we have 46,600,000, and that equals 4.66 times 10 to the 7th. This right here is your scientific notation. This is your standard notation. I'll write that for you. Standard and scientific. Standard notation and scientific notation. Okay? So how did we get to this 4.66 times 10 to the 7th? Well, it's actually pretty easy. First, we look at our sig figs. 466. Those are our sig figs. We're going to write 466. Now, when you're changing from standard notation to scientific notation, all you have to do is simply put the decimal after your first digit. So this becomes 4.66. Okay? Now we're going to have that times 10 to the something power. Well, how do we figure out what that power is? It's very easy. We look at our standard notation right here. We're going to have our decimal right here between the 4 and the 6. So how did we get from the original decimal place to here? Well, we moved 1, 2, 3, 4, 5, 6, 7 places. So this becomes 10 to the 7th. Another way to look at this is simply that it's 4.66 times, and what would 10 to the 7th be? Well, 10, and how many zeros are we going to add if it's to the 7th? We're going to have 7 zeros. 1, 2, 3, 4, 5, 6, 7. Add our commas. You'll notice that we have 4.66 times 10 million. Well, if 46,600,000 was our standard notation, you should be able to see that 4.66, or 4 times 10 million, gives you 40 million, and here we have 46,600,000, so that's where the 0.66 comes into play. So you kind of see where this is going. It's pretty simple. For our next example, we're going to go ahead and try writing 706,000 in standard notation. So here what I'd like you to do is pause the video.